So this next video is on CC8, which is acids. I don't have much to add here because it's generally a really strong topic for everyone. One thing to note though, in a neutralization reaction, you react an acid and a base and you form salt and water. I know the majority of you will know that already, but it's one thing spotting that when you're doing the acids topic, and every reaction we're looking at is neutralization. It's another when it's mixed up with all of the other content. The acid will be easy to spot, but the base, you need to know how to spot a base, so you're not going to know how to complete the equation. So there are three common types of bases: metal oxides. So here I've got calcium oxide, but that could be lithium oxide, that could be iron oxide, anything. If it's a metal oxide, it's a base. Metal hydroxide, so I've got lithium hydroxide here, it could be sodium hydroxide, or if you've got a metal in front of carbonate, so calcium carbonate, copper carbonate, any metal in front of oxide, hydroxide or carbonate is a base. And you need to be able to spot that, because once you spot you've got a base reacting with an acid, you should hopefully know then that you're forming salt and you're forming water. If we just look as well, because sometimes students get confused and they can't remember if you're forming water as the extra product or if you're forming hydrogen, okay? You're definitely forming water when you've got an acid and a base. The hydrogen in the water comes from the acid, and if we look at the bases, they all contain oxygen. So calcium oxide, calcium hydroxide, calcium carbonate, I've got oxygen in all of the bases, so I'm able to get oxygen from the base, and together I end up forming water. There's another type of base, ammonia, okay, so NH3 is a base, and if you react it with an acid, you'll form a salt, but you will not form water, okay, so that is an exception. It's still a neutralization reaction, but you're forming salt instead of salt and water. The other reaction we look at in the acids topic is we take our acids and we react them with metals. You still form the salt, but this time you only form hydrogen, and again, if you look, you should be able to see why. You're forming hydrogen, you get the hydrogen from the acid, but this time there's no oxygen to form water. So it's a metal by itself. You're acting an acid maybe with magnesium, okay? Magnesium doesn't have any oxygen, therefore I don't have any oxygen to combine with the hydrogen and form water, and my second product is just hydrogen. So acid and metal, salt and hydrogen, because there's no oxygen from the metal. Acid and base, salt and water, because the base provides the oxygen to form the water. The other thing that I do remember a couple of people having problems with is, why does adding an alkali to an acid increase pH? And I know you'd all probably quickly tell me that an alkali neutralizes the acid, and that leads to an increase in pH, but the mark scheme wanted more than that. You need to know that pH, when you're getting the pH, what you're actually doing is you are measuring the concentration of H+ ions. pH is you're measuring concentration of H+ ions. That's what pH is, and the reason pH increases when you add in an alkali is because the OH- ions from the alkali, the OH- ions react with the H+ ions, and that decreases the concentration of H+ ions. Okay, so if you've got lots and lots of H+ ions in a beaker, if I've got loads of H+ in there, that's going to be very acidic, and I'm going to have a low pH. If you chuck in some OH-, the OH- will mop up the H+, and you'll get lots of H2O formed, and you're going to have less H+ left in your beaker. Less H+ makes it less acidic and gives you a higher pH. But in terms of how you answer the question, you need to be quite specific. The alkali provides OH- ions, they react with the H+ ions, that decreases the concentration of the H+ ions, which increases the pH. You could also write that ionic equation, H+ plus OH- goes to H2O. That's what's actually happening. Other than that, I think acids is generally quite strong. Again, if you look at the specification, they've highlighted the start of the acids topic, but they haven't highlighted the end. They haven't highlighted the bit about making a salt using excess base. They also haven't highlighted that precipitation table. So it seems to be more at the start that they've highlighted, which is just acids and bases in general, alkalis, neutralization reactions, strong acids, weak acids, knowing the difference between the two, knowing the difference between a strong acid and a concentrated acid. So make sure you do read over that, but in general I think acids has always been quite strong This is the question that kind of I remember as being a source of weakness from a previous exam paper.